Here we go, radical equations, example number 6. You know, in my opinion, it doesn't do any good to learn this unless you can apply it. So we have a couple applications of what we're talking about here. Here's a formula I found that's related to basically the idea is that the variable W in this equation is the speed of the wind as it hits the exterior wall of a building. So pretend we're outside. Aren't the birds chirping? It's beautiful out, isn't it? And the wind is blowing against this wall here. And so the W is the speed of that wind in miles per hour, all right? And then the variable P is the amount of pressure being exerted on that wall, pounds per square foot. Now, you don't even really have to understand the background of the formula to do the question. One of my goals is to get people not so scared of applications. So you got W is wind, P is pressure, and those are defined here. So anyway, as we read this, it says, how much pressure? And I would go, wait a minute! They want me to find P when they ask me how much pressure. So P is going to remain a variable, isn't it? All right, that's a variable. How much pressure would a 60-mile-an-hour wind produce? So that 60 is the speed of the wind. So we replace the variable W with 60 in this situation, and we leave P as a variable. All right, so there you go. So, read the question, locate the numbers and put them in their appropriate spots, and whatever's left standing, that's your variable. So anyway, we're solving for P because that represents pressure, and this is a radical equation. I got excited when I saw it in the construction book. I can use that when we do radical equations. Isolate the radical. There's your radical. You look at the 0.5 and you say, how do I get rid of it? What's it doing to the radical? Multiplying, isn't it? Okay, so if that's a multiplier, wouldn't we want to divide both sides by the 0.5 in order to get rid of it? And so 60 divided by 0.5 is 120. And that gets rid of the 0.5, and we're left with the radical all by itself. There you go. That's exciting, isn't it? Okay, so we've got the radical by itself. Now we want to get rid of that radical. And look, since that's a square root, wouldn't we get rid of it with a squared? Exactly. So second power would be the appropriate radical to, or the appropriate power to introduce to both sides. I didn't plan ahead very well for board space here, but you can handle it. So 120 times 120 is 14,400, I think. You're sitting there with your calculators as I write this down. If you would please confirm for me that 120 times 120 is 14,400. Let's see, you're confirming for me, aren't you? Yes. Thank you, guys. It is. Yeah, did say yes. 14,400. Okay, cool. And look, I'm hoping you'd look at this and you'd realize that that's a P to the first power. It's linear. But look, if you want P by itself and it's being divided by something, wouldn't you introduce multiplication? And again, apologies, I didn't plan ahead very well here. Let's carve out some space. But that would be, let's multiply both sides by that number there. Great planning on my part. Well, sometimes things come along in life that we don't plan for, right? And this is over 1, so it cancels and leaves P, yay? And then you take that decimal times 14,400, and off the top of my head, I want to be truthful, off the top of my head, that comes out to be 9.2088. And, again, I'll be gracious with you. This is an unusual circumstance, obviously. But if you would try to remember anytime you do an application that you put the unit of measurement with your number, and it does mention in the narrative that pressure in this example is pounds per square foot. So put that unit that's in the narrative in the definition of that variable, and there you go. So what we just learned is that a 60-mile-an-hour wind would exert that many pounds per square foot of pressure on the wall, the exterior wall of a building. If you read this, it says that a common building code is 20 pounds per square foot. If it's built to code, it should withstand 20 pounds per square foot. This is below that. Shouldn't be a problem. Anyway, interesting application in my opinion. We'll do one more radical example. Radical.